Now question 11 says P is the any point, not midpoint, not anything. It is just in the interior of the ABCD, and it's a point in the interior of the rectangle ABCD. We are supposed to show that the sum of area of this triangle and this triangle is half of the area of this entire triangle, and also the sum of APD and this triangle BPC is equal to the sum of the area of these two triangles, this and this. Triangle 1 and 2 equals to half of this entire rectangle, and triangle 1 and 2, sum of 1 and 2 is equal to triangle 3 and 4. That is the requirement. See, this is again a beautiful problem. Now by construction we draw a line here parallel. EF is parallel to AB as well as DC, just drawing a construction EF. By that we have a parallelogram here and a parallelogram here, a rectangle, two rectangles, and now I am dealing this rectangle and this triangle, and therefore this triangle will be half of the area of this rectangle. Similarly, this triangle area will be half of the area of this rectangle, and if I add these two rectangles I will get the complete rectangle area, and if I add these two triangle areas it will be equal to the area of the whole rectangle. So the thing I have just now explained has been elaborately written over construction, the parallel lines, that part of the rectangle and this part of the other rectangle, and then adding this rectangle and this rectangle will give the whole rectangle ABCD, because these two, the summation will be the total rectangle, and LHS will be these two triangles, and the first proof stands achieved. And on similar lines, now we construct a line LM which is parallel to AD as well as BC, and again we have this line, and this is one rectangle and this is one rectangle, and rectangle and the triangle are exactly in relation. This area is half of this entire rectangle, and this triangle is half of this rectangle, and clubbing these two rectangles will give this entire rectangle, and summation of these areas of these two triangles, and the same has been elaborately written all over here. And the final component is putting these two triangles together. We have, since both these areas, since this triangle equal to half of this rectangle, and this two triangles are also equal to half of this rectangle area, therefore both this pair and this pair being equal to the same rectangle, therefore by Euclid's axiom 1, things which are equal to the same thing are equal to one another, and that is what has been clearly written over here by Euclid's axiom number 1.